Well, hello everybody. I was searching to see if I had a help video from last year for 106, and I don't. So this is Algebra 2, Semester B, or second semester. We're going to look at quiz 106, the sinusoidal graph's vertical shift. Now, even though it says vertical shift, it's actually going to talk about all of the stuff, all of the things, amplitude, period, and vertical shift. So I wanted to get this out to you guys. For those of you who are already kind of forging ahead, that's great. Remember, you have all 3 attempts on quizzes, so I recommend trying them. They're practice problems. Write it out. Use Desmos. Use your notes. Use your book. Use me. Use these help videos. Use whatever is going to help you be successful. That is a very good skill to have in life. Just use what resources you have. Obviously, except just directly trying to Google and not think about the answers or just search for the answer or whatever it is that strategy. If it's not a memorization thing like facts or definitions and it's an application, don't do that. Try to look at how to apply it because that's what's really helping your brain. And that's the point of high school. You're just going to try to use resources and your brain, graduate, earn those points, earn the credit, and then boom, start your future. Okay. All right. And there is no Googling your future. Okay. All right, here we go. So view and copy. Couple of things that we're going to talk about. Let me shrink my face. You're going to have different variations, but we talked about some key features for sine and cosine. So we need to put that in our brain for this. Will you use it in real life? I don't know. I really don't. I know music editing, I know actually a lot of video editing does use these type of graphs. You do want to look for those key features and match them up depending on where you splice and dice your recordings and videos. So maybe it's a great thing to practice here in math class, looking for those key features and thinking about them and then applying them later on wherever you might see them. Now, the overall skill is still just a really great practice, right? You are exercising your brain. Your brain is a muscle. Okay. If you remember from class, if you don't, that's okay. Pull up your book, pull up your notes. I happen to remember, so I'll talk about it and help you here. We had 2 basic, what we call parent functions. We had sine and we had cosine. Okay. Couple of key features. The sine graph starts at the origin, right? Starts here. It's going to go up first, come back down, and boom. That's the key idea. Some key basics for the sine function, sine of x, is it has an amplitude of 1. So that's 1. That's -1, right? Because the distance from here to here is 1. It has a period of 2 pi. So that's 2 pi. Okay. Then you can always split up your graph into fourths. You can chunk the changes into fourths. So if you start at a midline, you have 1/4 or pi over 2 to get to the max, another fourth or just pi back to the midline, down here, 3 pi over 2, back up another fourth, 2 pi. All right, we have some changes that we've talked about. We've talked about amplitude. What is the amplitude of this? Oh, here's a 1. That looks like it's about half. So I would say the amplitude is 1/2. We have to be careful because at this point we do have vertical shifts. So wait, let's take a look. Let's slow down. Where's the midline? The midline is indeed y = 0 or the x-axis. So we're good. The amplitude is 1/2. What is the period? Well, b will be equal to 2 pi divided by the period. What? You said the period is equal to 2 pi divided by b. Yes, it is. But if you just rearrange and solve for b, you get the same thing, right? See, rearrange, try it. But anyway, what is the period? So we do 1 full cycle, up, down, back. Aha, the period is 2 pi. So b would be 2 pi divided by 2 pi, which is 1. The period doesn't change, so it's 1. So now I know the amplitudes. I'm not going to talk about cosine would start up here. So cosine would start at its max, come down, come back up, kind of make like an ice cream cone shape, right? Before repeating. Well, this one clearly starts here. So we know it's going to be sine, but look, It's going to be a sine graph. It goes down first. So we know it's going to be negative because it's going down first. 1/2, because that's the amplitude, sine bx, just regular x, because b is 1, because the period didn't change. The period didn't change. So when they ask you what is the equation of this graph, you have a couple strategies. You could take it apart. You could pick it apart. First, is it sine or cosine? That's going to help you a lot. So basically, is it starting at the origin and going up or down? That's sine. Is it starting at 1 or is it starting up or down? Because the amplitude could change it. If it's starting already off of the origin, that's cosine. It's either going to start at its max or start at its min, depending on if it's a reflection. Okay, if it went up, it'd be regular sine. Oh, but it's going down first, so that's that negative. What is its amplitude, or the number in front, the coefficient? The amplitude is the absolute value of that, so the absolute value of negative 1/2 is 1/2. But look, you can see that. Look at the height from the midline. 1/2, right? Not quite all the way up to 1. And then you check the period to see what the coefficient is, which is just 1. Negative, which function? Okay, that's option 1. Negative 1/2 sine x. Again, we looked at this. All right, it's going down, so I know it's going to be negative sine. That's the only one. That's the only one that's negative sine 1/2. Check the amplitude. Yeah, it's about half. It's not all the way to 1. See? Cool. All right, that's how you would solve for question 1. Let's take a look at question 2. We'll talk about some other things. Ooh, all right, here we go. We have this graphing tool. We can do it. When you have this graphing tool, you need to find the midline first. You need to find a point on the midline, so where the graph crosses the midline. Look at this. There is no plus number, 2 cosine x. So you know the midline's at 0. That's excellent. We know the midline is at 0. Y equals 0. It's a regular cosine function, so it's going to start at its max. We can figure out the max based on the amplitude. That's 2. So this is going to be 2. 1. There is no b, there is no coefficient in front of the x variable, so the period is going to be 2 pi, which means it'll come back up to its max when we're done. Remember, we can break it into fourths. So a fourth, it'll be like about here. Another fourth, it'll be its min. Its min is going to be the opposite, right? If the max is 2, the min is going to be negative 2. And then it's going to cross the midline again at a fourth. So here are key points. If it's 2 pi, this is pi. This is 3 pi over 2. And then this is pi over 2, right? Fourths. So it's going to start at 2, come down, cross the midline, hit its min, come back up, and reach its max. Okay, so that's going to help us. I wanted to sketch that first. Do a hand sketching, help yourself, or find those key points that you know you're going to click. So what are the key points? The key point, it wants you to hit the midline first. So you're going to click pi over 2, if that's 3.14, so just do, what is that, 3.14 divided by 2 is 1.57. So you're going to click on 1.57, then go click the max at 0, 2. Okay, click here and then click there for this variation. Now, I would find that, I would sketch it, or even you go to Desmos Graphing and figure that out. Figure out the midline, click it. Figure out the max, click it. And it should do the rest for you. So mine's already going to be graphed, yours won't. Aha, so then, yeah, see what I said? Click here, click there, and it should graph it. Let's take a look. 7 sine x. Okay, so here it's sine. There is no period shift, so I'm going to click the origin. I'm going to click at the origin first because that's the midline. I'm going to go to 7. I'm going to click up at the top 7, but at pi over, or 1.57, just like I did before. Origin up at 7. Let's go see. They click different places. Oh, they click the min. No, so you could click the min if you wanted to. So again, your first click will be here, the origin, the midline, because to use this tool, you have to do this. Then I'm going to click 1.57, the max, because the period doesn't change. So this is the standard sine graph. The only difference is now the amplitude is 7. It didn't reflect or anything. So it's exactly the normal sine wave, only we flip it. Only we stretch it. I just said we didn't flip it. All right. Come on, brain. Here we go. Question 3. Almost done. Variation 3. Frequency. The frequency of a graph is 1 over the period. The period is how long it takes to do one cycle, right? I tried to do all different variations, but there you go. So let's go find the period. Here we go. We start right here. This is a cosine. This is a cosine graph. How do I know that? Because it's starting at a max. It's not reflected, so it's regular cosine. Its amplitude is 1, see? 1, -1. So we don't write it. It's invisible 1. So now I just have to think, what is the period? Well, I don't need to actually find B. I don't need to know the equation. I'm going to use the graph. So in order to use the graph, I just need to complete one cycle. Here we go. Aha. The period, I don't know why it's not letting me write, is one cycle. So up, down, back before it repeats. See how it's just going to repeat? Repeat. So one cycle, one complete wave is in pi. So the period is pi. The frequency now wants to know, like, if this was units of time, like how much of the graph or would be per 1 unit, like how frequent every 1 unit will we see it. So the frequency will be 1 over the period. So it's just going to be 1 over pi. That's it. That's the frequency. Frequency is the reciprocal of the period and vice versa. The period is the reciprocal of the frequency. That's it. 1 over pi, you should just type it, I think. What is going on? 1 over pi. Got it? Let's try one more variation. Okay, so it's cosine. Starts here, goes up. I'll use the graph. Goes down. Whoop. Pi over 2. Notice that. Goes up, goes down. Pi over 2. That's the period. The period is for one cycle. This is graphically the period. They don't give us an equation. They don't give us anything. So we got to look at it visually. Okay, if the period is pi over 2, that means the frequency is 1 over the period, but you can think of this as a reciprocal. So then the frequency, just flip it, 2 over pi. Okay. Question 4. Which equation represents the function of the graph? Okay, so you might have a choice. You can do stuff here, but we want to see what we can see. You could go graph those equations and find which one matches, but I'm going to talk about the key features. It starts here. What is that graph? It starts at the origin. Starts, right? Sine. It's a sine graph, okay? Is it a reflection? If it's a reflection, it would go down first. If it's not a reflection, meaning no negative sign, it would go up first. Okay, great. It goes up. So I now know it's a sine regular, no negative. What is the amplitude? The amplitude is 1, 1, 1. So there's nothing there. So it's just sine. So now all I have to think about is bx to get this equation. All right, well, I know that it'll hit its max in a fourth. It'll go back to the origin in half the period. It'll go to its min in 3/4, and it'll come back up, finish its cycle in 1 period. Obviously, I just need to look at the whole cycle, right? I was just keying in on those key features again to repeat some things to observe how to use this yourself when you're applying it. Think about the fourths. What's happening? Where does sine start? Where does it go up or down first? What does the amplitude mean? What does the period mean? Amplitude, period. Okay, so it's pi. Pi is the period. So how is b related? B is equal to 2 pi. P, the period is equal to 2 pi over b. So that means if you solve for b, multiply both sides by b, divide both sides by p, you'll get b is equal to 2 pi divided by p. Well, we just visually, graphically saw the period is pi, so we would have 2 pi over pi. Yes, the pi's cancel. Pi divided by pi is 1, so they cancel. It's 2. So you just have sine of 2x, regular sine of 2x. And that makes sense. It's going twice as fast, right? The normal sine wave would go up to here, crust down, come back here, and then finish. That's the normal sine wave. But now, 2 times x, it's going twice as fast. We'll do 2 complete waves in the distance that it used to take 1. I don't know. That helped. Boop. Ooh, they're being tricky. All right, last question. Nope. What is the period of the function? Cosine 10 of x, 10 times x. All right, so no matter which variation you have here, okay, 1/6, we'll do that one, 2x. All right, so whether you have, I'm going to do this one because it doesn't matter, but the fraction is a little bit harder and I can review some fraction math. The way to figure out the period of the function, again, period is equal to 2 pi over b. Is this called vertical shifts? There was not a vertical shift at all in any of these questions. They all had things to do with the amplitude and the period. They did not talk about the midline whatsoever, shifting the whole graph up and down. This would be a great time for feedback. All right, to be like, what are you talking about here? Why did you call this a vertical shift? Okay, let's go figure out why it's pi over pi 12. Okay, so again, the period is going to be equal to 2 pi divided by b, where b is the coefficient or the number multiplying the x variable. Okay, so let's just plug it in. 2 pi divided by 1/6. You can just multiply by the reciprocal, or you can divide by 1/6, which is keep, change, flip, copy, dot, flip, however you want to think of it. Basically, you change it to multiplication, you flip the fraction you're dividing by, and then you multiply. So this is the same thing as 2 pi times 6 over 1 if you want to, or 12 pi. Notice how we just multiply the number parts. 2 times 6 is 12. The pi stays. Okay. Very similarly, let's see, the question variation 1 was 10. So you're going to do the exact same thing. Period is equal to 2 pi divided by b, where b is the coefficient, the number multiplying the x. So you substitute it in, 2 times pi, 10, simplifies, 1/5 pi, or pi over 5. They're all the same. Seriously, there was no vertical shifts. No vertical shift. Oh, maybe. Let me see. Nope. Okay, this help video is done, but I'm just going to look at some of these. Nope. 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 No. Okay. So if you want to pause and try to see all of these, none of these have a vertical shift. All of these have to do with either the period, the frequency, or the amplitude of the graph, or not even really the amplitude. All right, that's really interesting. So again, thank you for watching. I hope this helps. These did not represent a vertical shift. So a vertical shift has to do with a number outside of the whole equation or the whole function. Basically, if we just added a number here or subtracted a number, right, These are the vertical shifts. They shift the whole thing up and the whole thing down. That's what's happening. Just so you can see that, we'll just do our regular cosine graph, okay? Plus D. So now if D is 1, it shifts the midline. Okay, let me do this. Y is equal to D. That's the midline. I'm going to make it dotted for you guys, dashed. Okay, let's zoom in. So this is just a regular cosine graph. Normally D is 0, so let's go back to 0. Right, there's our normal cosine graph. Let's take this off, boop. Okay, beautiful. But now D, a vertical shift, is also the midline. So whatever D equals, so D equals 2, it shifts it up, the whole thing up 2, but notice how the midline is now 2. D plus 2 would be the vertical shift. You shift your whole graph up 2, but now your midline is 2. Y equals 2. Say we want it to be -1. Cool. We'll just go -1. Boom. Whole thing shifts down. What if we wanted -1.5? It's okay. Shifts down. So vertical shifts are pretty straightforward. When do they come into play? You need to take a look at the vertical shift whenever you're trying to graph it or determine those key critical points, because now it's shifted up or down. So now your Y values will change, your X values will still stay the same, depending on other things, but like your amplitude. So now when this is normally 0, we can tell like our amplitude, the number in front, let's say it's 2, we know it's going to be at 2. But now if it has a vertical shift of 2, to figure out that point, we have to shift the whole graph up 2. So now our new starting point is at 4. It's no longer at 2 because the max is now 4 because we shifted the whole thing up 2 units. All right, food for thought. That quiz did not assess that content, so keep an eye out for it in future quizzes. We'll keep talking about it. We are just picking apart this sine wave. That's what we're doing. That's our goal. You can do it. Thank you for watching.